Kirchhoff's law. There are two Kirchhoff's law in electricity. So one is first Kirchhoff's law, another is second Kirchhoff's law. The first Kirchhoff's law we are going to study now is also known by two other names, which are junction law and current law. So Kirchhoff's current law, Kirchhoff's junction law and Kirchhoff's first law all are same. The names are different but they refer to the same quantity. So first of all, before going to this statement, let us go and find what the Kirchhoff's law is with example. So let us consider a wire. In this wire, the current I is coming at this point, which is my junction. Okay? So this is my junction, and another wire which is also heading towards the same junction, and the current be my, again let this be I1 and let this be I2. Okay, so how many currents they are coming at this junction? Two currents, they are I1 plus I2. And from this junction, let us consider another wire which is connected like this, and how much current there it should go. It should be my, let us consider as I3. Okay, but this I3 is how much? This I3 is my I1 plus I2, because I1 and I2 come here, and from this it went out. Okay, now again let us consider another current. Okay, this current has come here, and this value is my I4, and from this there is the outgoing current, which is my, say, I5, and this I5 is equal to how much? I3 is coming at this junction and I4 is coming at this junction, and this current should be equal to I3 plus I4. So this is actually the Kirchhoff's junction rule or Kirchhoff's current law, because here we consider the junction as well as here we consider what? We consider the current. Okay, so let me give you another example, which is a better example now. So there are how many currents? Let us consider this is my junction, and there are currents like this and like this. So it is all three currents. Say this is my I1, this is my I2, and this is my I3. So from this junction, let us consider there are two currents which are going out, going away, and these are my I4 and I5. Okay, I1, I2 and I3 coming at this junction, and from this junction I3 and I4 and I5 currents are going away. So at this junction, the Kirchhoff's first law says that the sum of all the incoming current at this junction, okay, that is the algebraic sum of all the incoming currents at this junction, that is I1 plus I2 plus I3, that is sum of all the currents coming at this junction, is equal, this is the statement, is equal to the sum of all the currents going away from the same junction. So what are the currents which are going away from the same junction? They are I4 and I5 and the sum. So this is my, what is this? Is my current law, junction law of Kirchhoff's first law, which states that the algebraic sum of all the currents coming at this junction is equal to the algebraic sum of all the currents which is going away from the same junction, and this is the equation. In some book you may find this, you can bring this I4 this side, you can also bring this I5 this side. Okay, that is another way, we don't go to that one. Now one more thing, very peculiar thing, very important thing is that on what basis this Kirchhoff's first law is based on. So it's based on the conservation of charge, okay, which I will explain. It's based on conservation of charge. We have studied this, please check this spelling. We have studied this in chapter 1, what the conservation of charge is. Now let me explain you why it is based on conservation of charge. So let me consider these two current which are coming in this direction, I1 and I2, and from this junction it is going as I3. Okay. So what do you mean by current? This is my junction. The current is flow of electron. For an example, let us consider there, okay, at time t equal to 0 second, okay, before starting anything, here let the charge is equal to 0 at junction. So at this junction the charge is 0. Okay, I am explaining the conservation of energy, conservation of charge. So from here, how many current? Okay, let us consider in first I1 there are, say example, 100 charges, which is my electrons coming per second. Here also let us consider 80 electrons coming per second. It means that coming per second, here how many electrons are flowing? 100 electrons in 1 second. Here 80 electrons in 1 second. So at this point, how many electrons will be there? There will be 100 plus 80 is 180 electrons per second. There will be a passing of electron. So here how much will be the current? How much will be the total charge? There will be 180 electrons per second. Okay, I have to add this. Now, if I here don't get 180 electron, if I get 170 electron per second, now what will happen? Tell me. Here in 1 second I should get 180 electron, but if I am getting 170 electron per second, what does it mean? It means that at this junction 10 electron per second is accumulating. In another 2 seconds there will be again 2 electron per second. In 1 more second there will be 10 electron per second. So in 3 seconds there will be 30 electron in 3 seconds in this point. But the conservation of charge says that whatever amount of charge is coming at this point, the same amount of charge should go away from this point. Okay, that is why if the current is the total current coming at this point is 3 ampere, then in this branch also, which is going away from this junction, there should always be 3 ampere of current. The total ampere of current will be same. Okay, if there is accumulation of charge, then there will be loss of current, which is not possible. It means that if the charges accumulates here, then the current will decrease, and if the charges accumulates here, it will not follow the conservation of charge. That is why sum of all the incoming current has to be equal to sum of all the outgoing currents here. Okay, sum of all the incoming currents I1, I2 and I3 is always equal to sum of all the outgoing currents I4 and I5, and so on. In the next lecture we study the Kirchhoff's second law. Thank you.